Hello, fellow. My name is James Owusu-Appiah, and I believe in innovation and doing things differently. This video has been prepared for you to guide you through some well-known concepts that will aid your studies and preparations towards exam. Due to COVID, we cannot meet in person to discuss, so I hope this video finds you well and helps you achieve excellence. Thank you.
Why am I open? Sorry. So let me just complete. Let me kind of complete that. Let me complete the diagram, right? So yeah. So now normally when we are filling a table, so all the signals we are interested in that we want to activate. After activating them, we have to keep all the other signals low. Else, then you see we have to keep those signals low, because if you don't keep it low, you see, because they are all connected to the same data bus. So if you keep them high, if you activate another signal on the right hand edge, it will kind of execute, whatever command that is it will execute it. So since all these other signals that we didn't touch, we will keep them low. It's important that we keep it low. So let me kind of try and then grade this one. The first one takes time, but let me just try and I'll just copy some copy and pasting will do. So let me copy and paste it here. Next time I wouldn't have to wait for that long. And I have to be careful, else I might shift something to the wrong place. Yeah, that's a problem. And so let me, okay, I'll keep this to 0 to a low, and let me copy the low again. So whenever we copy and paste another this thing, we have to kind of then let me shift this value back to where it came from. Hopefully we don't have to worry about that again after we have created this one already. So let me paste the next one. Okay, so let me, okay, I'm just trying to fill in that table, right? And just be focusing on where the main signal is, the main control signal, right, that we set. The other signals we set them to 0 because we're not interested in them now. Okay, let's keep them to low. But we have to be careful, else we would have set the wrong signal high, which is something you don't want to do. You don't want to do that. So we are sure this is the only signal we set high. So these other signals will keep them low. And we are just trying to grade a table, so bear with me. So I will keep this on low too. It's important. And here, what we kept high was the instruction number I just registered. So maybe I should have kind of done it first before doing that. But anyway, let's just do. So I'll keep this on low. Since we are not touching it, you keep it low. We'll keep this on 2 and move back. So this is what we activated, right? The instruction memory. Okay, we activated this signal. Which signal? This is what we activated. So let me keep track of these signals, else I might mess up then. So this is just a table. Let me take some time. Oh no, let's go back and then keep on filling this. All the other signals should be set low. Then we have keep the signal low. Okay, so we will end everything in a comma. Just permit me to do that, right? So let's see what I've done, what we have done here, right? So at this state of 0 0, we didn't care about any of the other inputs. We activated the program counter output enable. We output the content of the program counter to the data bus, and then we also enable the input of the instruction memory address register, because we want to read what is in the data bus into that register, right? So this is the only signal. These are the only signals we set high. The rest of the signals we left them low, because we are not using them, right? We don't want them to change or to do anything. So this is the first thing, right? So this is the first step. And as I said, at that step, after that particular step 00, once the clock rises, the value gets stored here, and when it's falling, this will detect a rising edge, and then it will increment. It will go to the next. So which means we are automatically going to the next step, to the next state also. So let's go to the next state. And what I'll do is that I'll just copy this line, this entire line, right? I'm just going to copy it, and then so that we can make the changes on it. It will be easier than doing everything. So what I did, I'll just copy this line, and so like I copy the line. Let me undo the copying first. So let's comment what we just did. This signal that we set, like what this particular line. Let's comment it. What we did, right? So by activating the signal, what were we doing in this particular state? So loading contents of a program counter into a instruction memory address register. So I'm just going to comment what I'm doing. Load content of program counter into instruction. Okay, now I'll use the short form of these things. Okay, load content of program counter PC into instruction memory address register, which is IMAR. So that's all we were doing, right? So the comments and things are not but it's good that you should comment what you are doing, because later you want to go through and then make changes. If you make a mistake, that's the comments help you to know what you are doing, so they can make the necessary changes. So this is step 1. And let me also write that we are executing so these are just comments, right? So don't care about that. So I'll just put something here, jump. Just tells us that we are executing the jump mission or something like that, just to have something. So these are comments. Our table still remain our table. This is what we are doing. This is the table, and this is the state that we just done. So let's go to the next state, right? Let's go to the next state and see what. So now at this state, we know the micro instruction counter has increment to this state now. So it's now 001. So we're at 00, and then we set up these signals, and the clock rises, and then they go executed. When the clock was falling, the micro instruction counter incremented because it has a negative clock input. So on the falling edge of the clock, it will see a rising edge, something like that. That's what has happened, and then we are now at 001. So when we are at 001, what do we want to do? You see, so let me remove this order. Let me deactivate all the signals at 0. Let me deactivate all the signals. So when we are at 001. So what next do we want to do? Well, at this stage, we know that the program counter, the content is already in the instruction memory address register. So which means the instruction is now visible on this line. So once this is visible on this line, we will activate this signal. We will set it high. Yeah, by activating this signal, right, we will output the content of what the instruction memory into what onto the data bus. So let's set the signal high, which is IM output enable. So IMOE. So let's look for that signal and then activate it. So where is IMOE? That's how it's good to label your signals. And make your life very, very easy. So you have IMOE. So this is the signal. I don't know, I should rename some of these signals. Okay, yeah, IMOE. So we will activate the signal. We'll set high. So we'll output the content of we'll output the content of the instruction memory, right? We'll send the output of the instruction memory to the data bus. That's what activating that signal will do. So once we have activated the signal, right, we'll know that what is in this memory is available on the data bus. And if it's available on the data bus, we want to read it into the current instruction register where we are fetching the instruction. This is the fetch cycle of our CPU, right? We are fetching the instruction. So we have outputted it here. It's already on the data line. Now, how do we want to read it here? So we will set the input enable of this particular register, right, of the current instruction register high, will activate the signal so that this register cannot be waiting for the clock to kind of latch in or to kind of store whatever is on this line. So let's activate, and this signal is called what? CIRRE. So basically, let's look for the CIRRE. So this is CIRRE. So set the signal high, right? So once this signal has been activated, set high, right? Now once it's high, so once we are done, let's comment what we are doing here. That way, so our comment, we always comment what is below it, so that you can see that the comment is actually assigned to what is below this thing. So I'll call it load instruction, load current instruction, okay, load a current instruction. So load current instruction into the current instruction register, right? That's our CIR, and we are done with that commenting, right? That commenting is out of the way. So once we have commented that, then so let's go back and see what has happened again. And I hope you try to follow along, right? Try and follow along, because so initially we activated the signal, it was high. Then we activated the input enable of the current instruction register, right? The data was on the line, and because this input is also connected to the same command, so this is the same data bus here, right? Extending all the way this side. So and then so because this is also activate high, it will just wait for the clock. So on the rising edge of the clock, this is high, and there's a data on the line, so it will be large and it will be stored into what this current instruction register, right? And then on the falling edge, this counter would have increment to what? To the next listing. So it will increment from what? From 001 to 010. Just how binary work. So we increment to the next here. Let me deactivate all this signal and then we kind of reactivate this now. So it's going to increment to the next. Oh, I'm not saving it now. Let me just keep that. So this will increment to the next listing, which is 01 to 10, right? So from 0001 then to 10. So at this step, you see, it's a nice now all the signals are deactivated. So at this step, what next to do? We always, because now we don't care. We still don't have the current instruction, so we don't care about anything else here. We also don't care about this thing now. So we just focus on what we have at this stage. So now see the interesting thing that has happened. So see the interesting thing that has happened, right? So we have been able to fetch the instruction from memory, and then we are put it into the current instruction register, right? So at this particular step, right? At this step 010, the instruction is actually available now, because remember in this step, right? The step above here, right? We loaded the current instruction into the current instruction register. So once the instruction has been loaded into the current instruction register, so which means we now have the instruction. So which means we now have the instruction. So what we are going to say here is that, so if the instruction happens to be this instruction 0 0 1, see, which is our code for what? For jump. You see 001. Let's go back to our instructions. Jump has a opcode over zeros. It has a opcode over that's 8 bits opcode. But you see, see the connection here, right? This connection here, we ignore the what? We only took the first 4 bits and then ignore the rest of the 4 bits. Have you seen it? And it makes sense, because at this instant, those bits, because our current instruction register is just 4 bits, so we included this other 4 bits because we know at that instant it will not contain anything useful to us. That's how we ignore it, right? So just take the first bit here, right? 1 2 3 4, that is 0 0 0 1. So if you see here, this is what the code that we have is 0 0 0 1. So we are not assuming, right? So we have been able to fetch the instruction from the instruction memory register. We have loaded into the current instruction register. So at state 0 1 0, we are assuming that the instruction is now 0 0 1. Like it's like an if statement, right? So if the instruction is equal to 0 0 1, then we are now about to execute that instruction, right? So we have been able to fetch the instruction, and we have decoded it. Of course, we have it now. We know it's a jump, and then the next thing is to execute, that instruction. So let's now come to the execution of the instruction. At 0 1 0, we are now executing the instruction, right? So yeah. So with the execution, so let's see. To execute, we need to know what a jump does. So the jump is a jump to an address within the entire 256 RAM. So we know that after the jump, we know see where this increment in, they are very important. We know at the end of the jump, the location that we want to jump to, right, should be stored in the program counter. But first, see the jump, the form of the jump, right? The first 8 bits is the instruction, which we already fetched, and then the next 8 bits is for the operand, the location I want to jump to.